This is the continuation for the 7.3 notes, which covers square roots and the Pythagorean theorem in Math 31. Okay, so what we've got here is the second style or type of problem you're going to deal with, and that's where one of the two legs that form that 90-degree angle is missing. So here's our 90-degree corner, and we've got one leg that's given to us, but the other leg is an unknown length. So since you'll always label the legs A and B in these Pythagorean theorem problems, you want to label, it's probably easiest to label the unknown A and the other one B. You can do it the other way if you want, but the hypotenuse should always be labeled C. Okay, the Pythagorean theorem is a squared plus b squared should equal c squared. So what we have here is a squared. We don't know that one, but the b is 3, so I'll say 3 squared there. And the other side is 5 squared. Square both those numbers. 3 times 3 is 9. 5 times 5 is 25. And now you're going to subtract 9 from both sides. So you'll write down, take it over to the other side and change the sign is one of the easier ways to do this. And you're really subtracting 9 off both sides when you do that. A squared will be equal to 16. And now we counteract the squaring. Square root both sides. So you get a value of 4. 4 times 4 is 16. So that length there has to be 4 centimeters. Okay, here's another example just like that. We have a hypotenuse length of 17. You can tell it's a hypotenuse several ways. One, it's the longest side of the triangle. 2, it's across from the 90-degree corner. I could write 90 degrees there in that corner. And the other thing is the two sides that make up the 90-degree corner are called the legs, and they're always labeled A and B, so by process of elimination, you're going to have C be the other side. Probably the cross from the 90 degree is the most dependable way. Okay, so A squared we don't know, plus B squared, we're going to put an 8 there, equals C squared, so 17 times 17, eventually we're going to put that in. 8 times 8 is 64, and 17 times itself is 289. Okay, now you're maybe used to seeing it written this way, where you subtract 64 from both sides. I tend to do it a little differently. I like the style where you take it over to the other side and change the sign. There's a lot of times when that'll save you steps. Anyway, subtracting 64 off both sides gives 225 here. And I happen to know that that's 15 times 15, so when I take the square root, I'll get 15 here. 15 miles. These are really long side lengths here, 8 miles and 17 miles. Those are city-sized lengths in some cases. Okay, here's another example of it, the 90-degree corner here. You've got to find that first and label the missing leg A and the other one B. And across from that 90-degree corner is your C value, or your hypotenuse length. The hypotenuse is just the technical name for the longest side of a right triangle. Okay, so A squared plus B squared equals C squared. I'm going to go ahead and write down the equation. That's called the Pythagorean theorem. And we don't know what A is, so we'll be content with using a letter to represent it. We're going to use 8 for the B value and 14 for the C value. So if you take 8 times 8, that's the next step here, and 14 times 14, and we'll subtract to get the A by itself. Subtract 64 off both sides, and if you do the math here, you get 132. Okay, unlike the previous problems, this is not a perfect square. Now we can get fairly close just by thinking about it for a minute. 10 times 10 would not give 132. It'd be shy of it, in other words, too small. 11 times 11 is 121. That's still too small, but 12 times 12, we've overshot it. So we're looking probably at a number, well, not probably, it's a number between 11 and 12. And if you use your calculator, it tells you that it's 11.5. Now, the danger there is you'll think you just go in between them. Oops, A is 11.5, but it really isn't 11.5. We had to round on our calculator, so we put a little dot there or one of those squiggly equal signs to indicate the rounding. Okay, so 11.5 inches is a good estimate of the length of A. Okay, we have a rectangle here with a diagonal thrown in, and that diagonal is the longest side of the right triangle that's formed in the lower half. It would be a mirror image of that one up there, just a rotated image actually. So what we know about this is that the screen measures 32 inches on the diagonal. Televisions are measured on their diagonal, so 32-inch television has that length diagonal. And the actual length of the rectangle is 25.6. So the missing side I'm going to call A. I'll label this one B. And that hypotenuse, we'll call that one C. All right, so A squared plus 25.6 squared is equal to 32 squared. If you leave those squares off, it doesn't work. All right, so the next line, and we're going to figure out what 25.6 times itself is. And that would be 655.36. And on the other side, 32 times 32 is 1024. Now, if you subtract the 655.36 off both sides, it gets you down to A squared is equal to 368.64. And all we have to do is take the square root of both sides. And the square root of A squared is just A. We'll have to round over here. It's going to be approximately 19.2. 19.2 inches. That's the width of that television screen. Okay, looks like we got a couple more problems here. And then a full another page. Okay, what is the straight line distance between third base and first base on a Little League field where the bases are 60 feet apart? Well, if we call this A and this one B, because of that 90-degree corner, it's convenient because we usually put a 90-degree symbol in for home plate. This one here is the hypotenuse, so it'd be C. So we have A squared plus B squared equals C squared. And that's the one we don't know. Okay, so 3600 plus 3600 is 7200. And now to counteract the squaring, you square root both sides. And that takes us down to C is approximately 84.9 feet. Your calculator will tell you that if you type square root of 7200. Okay, we got a ladder leaning against a house. The ladder is 10 feet away at the bottom and 24 feet long, so how high does it reach? We got our 90-degree corner right there, and the side length A is the one we don't know. So it's going to be A squared plus the B squared equals the C squared. So A squared plus 100 equals 576, 24 times 24. Subtract 100 off both sides. I won't show it, I'll just do it. And then we'll take the square root of both sides. And that takes us down to our A value of approximately 21.8 feet. Okay, the Pythagorean theorem can be used in a backwards direction. You can test to see if it works, and if it does, you conclude there's really a 90-degree corner. So a lot of times carpenters will use this to see if a wall is square. In practice, they'll often just measure the diagonals on this in this situation. But there's a famous triangle, a 6, 8, 10 triangle that's used. And carpenters know ahead of time that 6 feet, 8 feet, and 10 feet will give a right triangle. And if you put the two legs on the 90, what you hope to be the 90-degree angle, the 6 and the 8, you should get a 10-foot diagonal. So let's see if this actually works here. 6 squared plus 8 squared, does it equal the longest side 10 squared? You always want the longest side to be C, and we're going to put a little question mark above that equal sign. So 36 plus 64, and 10 times 10 over here, and you get 100 on both sides, which really is equal. And since that's true, then this 90-degree would be a yes. We've got a perpendicular angle there. It's square. That's how you want your wall to be. Okay, another application of this, you've got a tower that's 120 feet high, and the cable is tied 80 feet from the base, and you got a guy wire that's 135 feet long, and you want to know if this is level ground. Well, if it's level and your mast is vertical, then that would be a 90-degree corner. We're not sure it is yet, so we're going to test that. Okay, the two smaller sides are the ones that are A and B. And you don't know that these are equal, so you put a question mark there. If they are, you'll say, yeah, this is a 90-degree corner, and the conclusion then would be we've got level ground. Okay, so 6,400, that's what 80 times 80 is, plus 14400, or 14,400. And does that equal 135 times 135? And I did this earlier, it's 18,225. On the left, those numbers add up to 20,800. And you can see that's not equal to 18,225. And our conclusion is that it's not a 90-degree corner. And since the mast is presumably vertical, we conclude that, therefore, that 3 dots there, the ground isn't level. Now, that's not very surprising. Usually these masts are done on mountaintops or high ground, and so you're kind of expecting some slope here. It's just not very common for a mast like that to be put on perfectly flat ground. I can see a situation where if you're out on the plains of eastern Kansas or western Kansas or eastern Colorado, that the mast would have to be on level ground because that's all there is. Okay, so that does it for us, and I hope this really clarifies how to use the Pythagorean theorem. And in a separate video, I'm going to give you a few pointers on if you don't know how to type your square root, I'll show you how to do that.